Very good afternoon to everybody. Hope all is well. We had snow today for those that are on the East Coast, just to highlight that and let everybody else know who's not on the East Coast. But thank you very much for joining us today. My name is John Hyde. I'm the Assistant Director of Career Development and Alumni Services here for the Data Science Institute at Columbia. Today's seminar is an iCubed. For those that don't know what an iCubed is, stands for Institute, Industry, and Innovation. These are seminars that are connecting our industry affiliates to our students and the larger, broader Columbia community, hoping to explore topics at the forefront of industry. We invite our data scientists and engineers and researchers from affiliates to give talks on recent projects or case studies they've been involved in. During these educational events, we encourage attendees to ask questions via the Q&A chat feature so that we can take those and hopefully address them at the end. Today's talk, today we have a data scientist speaking to us from Stellar Development Foundation, and today's talk will be on anomaly detection and data usability on the blockchain, presented by Sydney Wiseman, who is a senior data engineer at Stellar Development Foundation. Welcome, Sydney, and thank you so much for joining us today from the West Coast.
Thank you, and thanks for the introduction. So today, like John said, I'm giving a talk on data on the blockchain. So we're going to cover data usability as well as some anomaly detection case studies that we've done. I am a data engineer. I am not a data scientist. So this is going to be a more data geared talk that's going to focus on some infrastructure that we've built out and some opportunities where I see that we could have data science applications in the future. So I work at Stellar Development Foundation, which is a nonprofit organization to support the development and growth of an open source Stellar network, which is a blockchain payment network. In a past life, I was a machine learning engineer, so I do have a pretty broad background in data science and have a perspective of some of the past struggles that data scientists have had when trying to complete projects, and how I think that blockchain could help with some of those. And so what I'm going to cover today is give a brief overview of what is the blockchain for those of you who aren't familiar with it, where I think that intersectionality between blockchain and data science exists, and then go through a couple of case studies and future applications. So what is the blockchain? Doing a simple introduction. I'm going to try and keep this explanation as simplistic as possible. I'm going to leave out some of how blockchain achieves some of its features and core capabilities and focus instead on what it can offer us. And hopefully by the end, we don't look like this crazy guy who just has a conspiracy theory about how blockchain works, but doesn't actually understand how it works. Advancements in technologies have made it so that information can be shared instantly with anyone in the world, regardless of where it came from. I can send an email to my friends in Japan instantly, even though they're on the other side of the world. The same, however, isn't true for money and other things of value. So even though you feel like you can send money instantly across the world, the challenge actually lies in the double spending problem. So I can send you an email and then send that same email to 5 other people, but I can't send you $5 and then turn around and give that same $5 to someone else. So things of value require a degree of confidence that, 1, I'm good for the $5, so do I actually have it? And 2, once that $5 is allocated, I can't respend it. This double spend problem drives how banks and other traditional financial institutions have built their systems. Since their existence, financial systems prevent double spending from happening, and they do this through a central authority to maintain them. The central authority has absolute power over what the database contains. This can run into issues, though, when security issues arise within the authority, because it's possible that the data can be altered or even deleted. Additionally, the centralized authority tends to be slow. So any service that needs to send or receive money must go through that one source in order to confirm a transaction and actually clear and settle the money. In traditional financial systems, each bank has its own centralized database that often follows its own schema, process flow, which creates a disjointed system when they try and connect with other systems. As such, these databases from one organization is often not interoperable with another, which leads to large delays when money is moved from one place to another. Have any of you ever tried to send money to a friend abroad who uses a different currency? While it may show up as sent, it can take actual days to settle those payments as your payment flows through several intermediaries. So if you're sending money to, let's say, somewhere in Asia, you might actually make a hop to Europe before sending it over. And each one of these intermediaries is taking a cut where you have to pay a hefty fee before it arrives. And that is even if people have bank accounts. So with the traditional financial systems, they end up excluding billions of people who do not have access to financial services as we know them today. As the world has become more connected and our interactions more digital, we've needed something more resilient and collaborative, something that will work at scale, but not be subject to a single political ideology, personal motive, or corporate incentive to manage our data. And this is really where the blockchain came in to answer that need. It was invented in 2009 after disillusionment with the financial collapse in 2008. In much of the same way that the internet democratized access to information, the blockchain can democratize access to the financial systems. It can make sending value around the world as easy as sending that email. While it was originally invented to fit modern needs of finance, the blockchain does not have applications limited to the financial sector. In reality, it's a kind of database or data store, but different from traditional databases as it's not maintained by a central authority. It's a method for keeping data synchronized across multiple independent stakeholders, which are often called nodes. Where a traditional database is perfect for tracking records for a single entity, blockchain allows groups of entities who might be unrelated and who might all have incentive to alter their shared data to agree and maintain a single immutable data set. And so if you're trying to think of an example of what is this data that we're talking about that could be on a blockchain, it's honestly just a simplified ledger. So for centuries, people have tracked information using a ledger, a simple chronological list of data, like the one that's displayed on this slide. So on most popular blockchains, each one of these entries, whether it's a payment or a trade, are called transactions. So if Lisa sends $50 to Billy, that's going to be one entry in the ledger. And they're timestamped and contain information that's unique per transaction. The main difference between this ledger and an old ledger, so if you think of traditional ledgers, they can be modified. If I wanted to go in and erase one of these transactions, let's say I wrote down Anka sends $40 to Tyler, and in reality she sent $30, I'd be able to go back and erase that. But the difference with blockchain is that it's stable. So the ledger is dispersed across multiple computers, and therefore it can't be lost or turned off, but it also can't be altered. So the data, once it's added to the blockchain, it's there for forever and it's publicly available and transparent. So in essence, the blockchain is a public timestamped series of immutable records of data, which sounds awfully similar to a database. And it's synchronized across multiple independent stakeholders. In order to guarantee that records on the blockchain are immutable, all nodes must agree that the transaction occurred as stated. So in traditional databases, the database itself decides when it can commit records to that database. However, in the blockchain, it's the series of nodes connected together use an algorithm to determine if the nodes agree on the transaction and think it's valid. And this is called the consensus protocol. And you may wonder why there's so many blockchain technologies today. And the reason is because many of them differ in their consensus protocols, which is why so many have emerged. So that gets us to what is Stellar. Stellar is one of those blockchains, and it specifically focuses on cross-border payments. It's an open source network for currencies and payments. It doesn't have an owner, and if anything, it's owned by the public. The software runs on decentralized open network, and it handles millions of transactions each day. So just like Bitcoin and Ethereum, Stellar relies on the blockchain to keep the network in sync, but the end user experience is more like cash. Stellar is much faster. Our ledgers close on average in 5 seconds. It's cheaper. Our average transaction cost is less than pennies, and it's more energy efficient than typical blockchain-based systems. Stellar makes it possible to create, send, and trade digital representations of all forms of money, whether that's dollars, pesos, bitcoins, pretty much anything. It's designed so that all the world's financial systems can work together on a single network. Now, you may be wondering what this has to do with data scientists or the current challenges in the space. And I believe that there's an intersection between the two that is mutually beneficial. So the data science, and I'm sure all of you on this call know this, although data scientists are referred to as one of the sexiest professions in the 21st century, there are a lot of dirty, unsexy facets of this job. So when polled by Forbes, 60% of data scientists claim they spent the most time cleaning and organizing data, and another 19% simply trying to collect this data. I imagine this also includes time spent trying to get the appropriate security access and cobble together a full data set. Common hurdles at companies include poorly documented data, unstructured data, and incomplete data, which is quite a headache when you're trying to build a training data set. This really leaves only 7% of data scientists claiming that they spend the most time building training data sets and refining their models. And sadly, this also corresponds to what data scientists claim were the most time-consuming aspects, or also their least enjoyable parts of their job. So a combined 78% of those polled least enjoyed collecting and cleaning data. And I'll admit this is an old poll. You can look this up. It was conducted in 2016, yet I think the sentiment still remains true today. So again, in 2019, a Twitter poll shows that the majority of data scientists' day is dominated by cleaning and moving data. The industry is seeing rapid turnover in data science because of this, with the average tenure of data scientists at current workplaces being 1.7 years, according to 365 Data Science's annual review. The high rate of turnover suggests that perhaps there are misaligned expectations between what a data scientist wants to do and the dirty work that actually goes into preparing data sets for exploratory data analysis and model training. Now, an easy conclusion from these surveys would be that data scientists spend too much time cleaning and organizing data. In reality, though, I think that data scientists spend too much time on the wrong type of data cleansing activities. And what I mean by this is that data scientists should be spending time working with the data. There is merit in transforming, exploring, and understanding the data in order to glean better insights that can be applied towards your problem. No matter how clean and standardized a data set is, even if you're pulling a CSV from Kaggle, it's always going to need work before it's ready for model training. You should not, however, have to spend large amounts of time validating that your data is correct or wondering if your data source is incomplete or untrusted. And this is where I think blockchain technologies can help solve some of the friction points experienced during exploratory data analysis. What they do offer is new approaches to old data integrity issues. So we covered that blockchain networks are distributed data stores, and what's novel about their approach is their guiding principles for data quality, traceability, and privacy. So first off, how can I trust the data I have? There's consistency on blockchain through consensus. So since no one validator is able to write data to the ledger, it requires agreement amongst the network, which means that once the data is written to the block, its presence is consistent among validators. The block that is written to the network is immutable, so it cannot be changed, deleted, or rolled back once it's committed. And this history is stored from the Genesis ledger through time, so you can be confident that you have a full, complete data set if you're pulling data from the blockchain. The consensus mechanisms and immutability together create on-chain validation. So a transaction cannot be written to the ledger unless there's consensus that that transaction is valid and in the expected format. And again, so with traceability, where did this data come from? Anyone can access transactions that live on a blockchain. There's no mystery as to the data lineage of a publicly available ledger. And because of this information that's publicly available, you have full access to the transactional history. If you want to trace an asset as it flows from account A to B and C, it's possible. And what's cool, since these technologies have been maturing over time, is that you don't even necessarily have to write code to do this. Most networks have user interfaces that allow you to explore blockchain data and fetch account information or single transactions from the raw source. And then lastly, with ethics of data privacy and protection, how is the data protected? And so there is, I'll caveat it with, there is pseudo-anonymity on a blockchain. So the blockchain records network activity, but it does not record personal information about accounts or those who own them. So from like the actual chain data perspective, you don't have to worry about GDPR or CCPA because the data is already anonymized. However, that's not to say that you couldn't pull data off chain and make educated guesses on which accounts are owned by which people. Furthermore, consensus protocols have built-in security through cryptography and decentralization. So bad actors cannot modify or submit bad data to the network, which helps prevent fraud on the network. Now, All of you have probably been watching the headlines. There are still fraud cases that happen, but it's more to do with bad actors stealing private keys for account holders and not the actual data on the network that's being modified. So the emergence in a focus on data validation is encouraging for fields like data science, but blockchains are not a panacea. So collecting large historical data sets is still challenging, and getting data off-chain in a usable format requires work. So there are several options of how you can do that today. One of the most common ways that you can procure these data sets is through public data sets. So GCP has exposed a series of public data sets for a lot of the blockchains today. Also, there are many Kaggle competitions that offer data sets for both Bitcoin and Ethereum. And lastly, there is some university research on the web, and you can download their data sets as well. For those who want more flexibility, there are APIs and SDKs where you can use client libraries or APIs to interact with the data directly. One thing that's cool about the open source community is that there has been a large contribution back to an ETL library, which helps you build data pipelines. And that library is called Blockchain ETL. Or lastly, you could write your own custom data pipelines if you're looking for a custom way to clean that data. Enterprise solutions are also quickly emerging. These are probably the quickest way to get a lot of data, but they tend to be really expensive. So some of those companies are Dune Analytics, crypto APIs, and BigQueries. There are many ways to interface with blockchain data, and Stellar recognizes the importance of a clear and straightforward option for access. And as such, we've simplified data access and collection through two services, an API called Horizon and a data warehouse, which we call Hubble. Both Horizon and Hubble have their own documentation and tutorials on how to use them, but I think it's also important to understand the overall data architecture of how Stellar Core, Horizon, and Hubble fit together. When we talk about the blockchain, we're actually referring to that series of independent nodes that run software and report the current state of the network. We call this program Stellar Core. And at its simplest, Stellar Core is simply a state machine. So at any given point in time, let's say a ledger, what Stellar Core does is it applies those transactions to the network, and then it updates the state of all of those variables based on those transaction results. So Stellar Core commits these transactions to the ledger, which can also be called a block, quickly, arriving at consensus about every 5 seconds before waiting for new state changes. And because it has to input these processes so quickly, and it has to process these inputs so quickly, it is optimized for network performance. Hence, this data is compressed in files and data structures which are actually hard to access on chain. Stellar Core is written in C++ code, and that code and data is cumbersome for everyday access. Stellar Core reports that current state of the network, but it cannot tell you how it got there. So if someone's balance updates from $100 to $200, it doesn't actually record that change data capture of how it got there. The need to access and interpret the data on chain required solutions beyond Stellar Core. Horizon is an API for interacting with the Stellar network that solves this very problem. It serves as a bridge between applications and Stellar Core. It can both submit transactions to the network, query an account balance, or stream live events like transactions into an account. So when used for examining on-chain data, Horizon returns flattened, human-readable response, making it easier to understand the data. Horizon's database structures and indexes are optimized for the exposed API, but doing deeper queries across different accounts or tables becomes highly inefficient. It's slow for historical queries for specific column values, which makes it decidedly worse for analytics. Horizon helps tell a story because it can show how something happened. Core keeps the state of an object like an account balance, but if the balance were to increase or decrease, there's not enough data to construct that story as to what increased that balance. To quickly understand behavior at scale, Stellar decided to build new infrastructure with analytics in mind. And this concept is relatively new for Stellar. So we started building out our data warehouse in 2020 and released it earlier this year. The solution we came up with is a well-established data architecture. So in order to ask historical trending questions, we need a database that could handle aggregations and processing large data sets. We decided to build Hubble as a data warehouse on BigQuery. One of the useful features is that Hubble is actually decoupled from this API Horizon. And we wrote a library, Stellar ETL, which mirrors that blockchain ETL pattern, where it ingests the raw data from source or Stellar Core, transforms the data into a normalized output, and loads that data to BigQuery. With this design pattern, we have no dependencies on Horizon. It can be we optimize the data model for historical and analytic purposes. So if Stellar Core reports what happened, and Horizon can tell a story about how the event happened, Hubble is the tool that actually diagnoses why that event happened. The key to these different data sources this is the key to the different data sources being able to tell different parts of the story, which lie in the data model itself. So in our data model, although Horizon and Hubble are two completely decoupled components, they share very similar data models today. And that is comprised of transactional tables and state tables. So transactional tables are the complete history of transactions and operations and can be seen more as like an event stream or a logging stream. These records are immutable and are not updated, and we typically call them the history archives tables. The state tables, on the other end, provide a snapshot of the point in time status of the network. So you can think of this as when you pull your bank account information and it tells you your current balance, what your credit limit is, and maybe like if you use Venmo or Zelle, who you are authorized to send money for, that would be considered a state table. When you download your banking statement where it shows all individual transactions that justifies why you have the balance you have, that would be a transactional table. So in Horizon, these state tables are current snapshots only. The records are actually upserted when there's an event that changes the data. So there isn't any history saved, meaning that it's accessing only the current state. And this is the biggest difference between Horizon and Hubble today. So Hubble saves every state in a version table with ledger timestamps for each state change. With Hubble, we are able to reconstruct network state at any point in time. We chose this data model because separately, each of these table types would provide an incomplete view of network activity. If only transactional tables existed, the user would not be able to easily understand account balances. And conversely, if we only had account balances, we wouldn't be able to justify why we got where we were. And so this is why our data model blends both state and historical tables into one complete network picture. The tables are able to interact together, and the amount of state tables that we make publicly available is actually a unique feature to the Stellar blockchain. So most other blockchains only make their accounts table available, and they do not expose their trust lines table, which is more of like a security of which accounts trust which accounts, as well as our offers table, which is our order book for our decentralized exchange. So most competitors include only the transactional and event information and rely on end users to reconstruct the state if they need it. We take a different stance, however, and want to highlight the importance of making blockchain data accessible and usable. One lesson the industry is learning is that quality data science requires quality data infrastructure. If you do not spend sufficient amounts of time ensuring that your data is usable, interpretable, and of high quality, you will be disappointed with either the time spent or the quality of the data science project that's produced. As the age-old adage goes, garbage in, garbage out. So beyond traditional business analytics and metric calculations, our primary use of Hubble today is for lightweight anomaly detection. We have introduced some simple heuristics that alert us to anomalous activity, which has helped identify some fascinating behavior on the network. Our heuristics alert us to rapid increases or decreases in trading prices, volume, and activity. Once we are alerted to potential issues, we are able to investigate the root causes and determine whether or not we need to take action. So I'm going to cover two case studies today. Our first example covers anomalous payment behavior we observed as part of our Stellar Quest program. Stellar Quest is a series of challenges that require you to accomplish tasks or coding puzzles with the Stellar SDKs. It's a program that's designed to encourage new developers to learn how our ecosystem works, and it rewards those who participate in the quests with badges and even prize money. When quests launch for the first time, there is a time component for the rewards. So the first 20 correct submissions for a challenge can win anywhere from 10 lumens to 500 lumens, which is the native operating currency on the Stellar network. At the current exchange rates, this is anywhere from $3 to $165. So the intent of this program is to solicit new engagement and education on the Stellar network, and it's geared towards junior developers. What happens though when malicious actors realize that they can sell these solutions for profit? So in such a scheme, one person creates a valid solution to the Stellar Quest and will share that solution with others on the promise that those who earn rewards from the solution share part of that reward back with the seller. While this isn't illegal, it does undermine the mission of the Stellar Quest program, and it weakens community participation. So this pattern was first identified because of a unidirectional nature of payments and irregular shape of the payment network originating from Stellar Quest accounts. These accounts were funneling funds into a single account with multiple disconnected accounts paying that one singular source. And this pattern didn't really emulate a traditional payment graph, which is why we started looking into it. So once this problem was discovered, we wanted a quick way to visualize closed rings of activity on the network to identify potential fraud in the Stellar Quest challenges. One of the benefits of the blockchain community is that you can crowdsource solutions to problems that you have. So one of our ecosystem participants was able to build an interactive graph that displayed all of the closed payment networks on Stellar. Now, I want to actually jump into this visualization because it's pretty cool. It was built with an open source graph network visualizer. And so what we're seeing here is each one of these individual nodes is an account that's on Stellar or a wallet that holds value in it. And each one of the vertexes in the graph is actually payment activity to and from these accounts. And so what you can see with this large cluster in the middle here is that we have a lot of disconnected accounts that aren't interacting with each other, but they're interacting with this one account in the middle. And what's particularly cool about this visual that our ecosystem partner made is that when you click on any of the nodes, it actually pulls up one of those UIs where you can view account activities. So we can actually see where this account is receiving a bunch of small Lumen payments from disconnected sources. And so from this visual, we were actually able to trace one of the wallets selling solutions. And though the prizes seem trivial, this wallet that we're looking at was paid the equivalent of $1,100 to sell those solutions. Now, it's important to maintain a human in the loop for some of these scenarios and not jump to conclusions. One of the conclusions that we could jump to is any of these closed rings would just lock out the account in the middle and be done with it. But as we started interviewing some of those smaller rings that looked more like concentric circles, they're actually collegiate study groups that were pooling funds together. So if they all won an award, they were pooling it into a single account so that they could use that account to actually invest more money. So without Hubble, these types of visualizations would not be possible, and they provide immense insight into why anomalies occur in our network. For our second case study, I wanted to it overviews the potential trading scheme that intentionally overflates trade volume to earn market rewards. And so this is called wash trading, which was super common in the actual stock market back in the 1930s. So for blockchain exchanges and networks today, liquidity can be a problem. For payments to execute across currencies, there needs to be money available in the asset, preferably in a stable, predictable price. Liquidity is that ease in which an asset can be bought and sold on a market. So let's say I wanted to exchange $1 for a Mexican peso. If there aren't enough Mexican pesos in the market, I either cannot make that payment that I would like to make, or the price could be high. And so this is a friction point for both new and established exchanges, but for different reasons. With newer exchanges, the lack of capital they lack capital to be able to attract users to their markets. Prices can be unfair, which leads to arbitrage opportunities or inactivity. And there isn't really freedom to be able to deposit or withdraw from any market. Now, in some of your bigger existing centralized exchanges, like Coinbase or Binance, these are pooled markets. So they give opportunity for high liquidity because they're pooling multiple smaller markets together. But the flip side of these is that they charge high fees in order to make a profit by making that liquidity available. And so one strategy to encourage market liquidity is to provide incentives to those who do provide liquidity to a network. This strategy is not unique to decentralized finance. Traditional finance does this too, and it offers the same types of incentives. So if you've ever held a money market or certificate of deposit, these are liquidity strategies for banks. You agree to leave your money invested with them for a period of time in exchange for earning interest off that money. Typically, these rewards need to be bounded with parameters that ensure that people leave the money in place in the market long enough to tangibly benefit the network. And I'm going to give you a hint as to what's to come. If that reward is improperly defined, if the incentive doesn't have the appropriate boundaries in place, it can end up creating loopholes for those looking to collect the incentive without fulfilling the actual liquidity requirements. So while this is going on in the background, another common way to improve liquidity is to actually introduce a feature called an automated money market to a network. So people can make deposits into these pools and earn interest. It's actually a pretty complex trading strategy, and it's a topic for its own talk. But one thing that's important to note is that Stellar had launched this brand new feature to support AMMs. And because of this, we were monitoring trade activity more than normal to understand how this feature was impacting our current baseline. About 2 weeks after the launch of AMMs, we were alerted to an increase in the number of transactions and operations committed to the ledger. At first, we were really excited by this news because it meant that we were seeing an increase in network activity. However, when we pulled the chart to actually see the transactions that were occurring, we noticed that we were reaching maximum capacity and almost all of the transactions on those ledgers were failed transactions. So in this bar chart, what you're seeing is the orange transactions are failed and the blue ones are successful ones. And so to inhibit network congestion when there are these spiky increases in activity, we have a surge pricing mechanism that increases those transaction fees when network activity increases. If the transaction is unwilling to pay the surge price, it fails. With this chart, what you should see is a count of trade conversions by month. So at the same time that we were seeing an increase in our ledger activity, we actually had our monitoring service alert us to an unexpected increase in the number of trades executing on the network. And so as you can see, we had this enormous spike in November, which is when we had launched AMMs. And this large increase directly correlates with the increase in transactions that we're seeing submitted to the ledger. So we're seeing a large number of trade increase, and that was corroborated with this graph here. So by this point, we were pretty certain that AMMs were what was creating all of this new activity on the network. However, we ended up seeing one weird item that didn't align with our hypothesis. So another area that saw a huge spike in activity was our cumulative active offers. These active offers had increased exponentially, but offers are not needed to transact with a money market, and they are not part of the AMM feature. So why were we seeing so many rapid increases in the offers on our network? So having all of these combined issues together, it was actually slowing down our network. And after a day's delay, our Hubble analytics alerted us that there had been an unexpected increase in the volume of traditional trades, meaning that these trades were occurring between individual parties instead of this new feature that we had rolled out. And the volume of trades executed on Bitcoin, Ethereum, and the native Lumen asset were increasing. So with this additional clue, we started investigating the root cause. Our initial assumption was that the release of the new AMM feature was causing unexpected market activity, but we ended up finding pretty surprising results. So as we looked for price changes with some of the assets on our network, we noticed that we were seeing this huge spike in trading volume, and we were seeing it across Bitcoin, Ethereum, some USDC stable coins. This animation is not working well. But one thing that we noticed, and this is kind of a quirk in decentralized finance, is that anyone can issue tokens. So if I wanted to issue the Sydney Bitcoin token, I would be able to do that, and you would just have to trust that my Bitcoin token was good for a Bitcoin. So we pulled some of our other Bitcoin assets that weren't spiking, and we noticed that they were flatlining or had no activity whatsoever. So it seemed like this problem was just isolated to a subset of assets on our network. And so then what did we do next? Next, what we did is we started pulling individual transactions, which really felt like we were looking for a needle in a haystack. but we wanted to see what was happening with trades between individual accounts. So what you're looking at is payments from one wallet address to another wallet address. And one thing that you might find really bizarre about this is that it seems like these addresses are sending the equivalent of one Ethereum token back and forth to each other over and over again. And as we started looking closer at this, we realized that it was the same accounts doing this over and over again. So these highlighted accounts, and I highlighted only some of them so that it was more readable, but you can see that is both the source for a payer for a transaction, and then it's the receiver for the same transaction. And what's interesting is that it's these two accounts sending this value back and forth. So they're in a closed loop payment system where they're not actually sending that value anywhere else. They're keeping it contained between the two of them. And we wanted to know how pervasive this trading scheme was. So what we did is we aggregated some of the trading data and calculated the total amount traded between individual accounts and the total number of trades executed to get to that volume. And what we found is that an amount of a Bitcoin was traded almost 700 times in a single day between an account pair, which was overinflating our network value by $400,000 because it looked like people were trading value, but really they were just sending it back and forth. And this behavior right here is a textbook example of wash trading. So what is happening with these accounts is they're overstating market activity by just sending value back and forth between them. And by selecting a relatively high value, there's low risk that somebody's going to step into this wash trading scheme and actually buy the Bitcoin because they're sending so much money between each other. And so in this example, the accounts were engaging in wash trading, which distorts price, volume, and volatility in financial markets. And the reason why they were doing this is they were chasing a liquidity reward. So there was a poorly defined reward on our network that incentivized people and paid them in actual currency if their trading volumes exceeded a certain value over a day. So what they were doing is they were setting up two accounts, trading between themselves and then collecting on that reward. And so how can we prevent this type of behavior? One option for us is something called a clawback, which is where we are able to take back the reward. But this doesn't always work because there needs to be an agreement upfront that liquidity providers and the reward provider can claw back the reward. So if this isn't decided on in the start with a contract, it's not actually possible to perform the clawback. Another option that we can do is we can charge a larger fee for frequent order book updates or frequent trades like the ones displayed here to try and disincentivize people from performing this. And then the last option that we have is we can work with partners on our network to identify accounts that are participating in wash trading and let the partners take action. And this is ultimately what we ended up doing. So in these two case studies, we were able to diagnose the cause of anomalous network activity and take action on it. However, in both cases, our actions came at a delay, which were reacting to past events. We weren't able to prevent fraud from occurring in Stellar Quest, though we can recover the funds after the fact, nor could we prevent the overstated network volume due to wash trading. And this is one of the areas where I really think that we could use data science and move from this reactive model into more of a proactive and predictive model. So the relationship between the DeFi industry and data science can be a symbiotic one. Blockchain technologies validate the data, and data science creates data prediction that can be used by the blockchain. Even though these fields would mutually benefit each other, we still haven't seen much intertwining between these two practices. So much of blockchain analytics space still focuses on descriptive analytics with some statistical insights and inferences, but little to no practical ML applications. There has been academic research, but little on-chain and off-chain predictive analytics are executing in production today. And this isn't because of a lack of appropriate use cases for data science. I think it's more due to a lack of awareness of each other. So I think the blockchain industry is just now realizing the importance of having some of these forward-looking analytical features built into their industry. And I think data scientists now are realizing that there is opportunity to work in this space. And so what applications do I see in machine learning that we are missing today? One of the most glaring opportunities is actually understanding network usage. Since the blockchain is an open source network, it can be extended to many use cases and it's not constrained to how it's used. Anyone who can code can spin up a project and solve any kind of problem that they want. And so one compelling item that we could do is we could build an unsupervised learning model that clusters network patterns and behaviors in order to label types of network activity that's going on. So although we're a payment network, are people actually using us to solve Internet of Things problems? They're using us to solve problems that we hadn't even thought of. Something like this could influence product development and drive new feature prioritization for some of the development foundations. A more forward-looking opportunity would be data-driven medical diagnoses. So the irony of having a decentralized data store is that it would actually centralize disparate data sets today, like medical records. These records are spread across all sorts of hospital systems, stored in different locations. There is an interest in moving medical records to a private blockchain network, which would modernize record keeping and centralize all records in one location. So one benefit of this model is that data scientists could get access to a robust, unified data set that would be used to build more accurate models, which could then be used to diagnose conditions faster. And lastly, data science could also be used for it could be used for price prediction. So you could use the historical price data that's available on most of the exchanges today and predict asset prices. So it'd be an easier use case with some supervised learning to forecast that pricing information. One area where I think this could be cool is that it could be integrated with off-chain event data to see if off-chain events actually impact on-chain price movement. So a silly example, but one that would show the benefit of this is when Elon Musk tweets about Dogecoin, it sends price up and down. So could you integrate some kind of social media data like that, either from players who were important in the industry or tag certain words, where you could then use the NLP scraped from those social media tweets and predict price movement that way. So this is an exciting industry with a need for more data science engagement. If this is something that sounds interesting to you, there are ways to get involved. So one of the easiest ways to get involved today is to participate in Stellar Quest. You could join the competitions, win prizes, and learn more about Stellar. It's a really fun community. The guy who organizes it is really smart and cool. Another way that you could join is actually joining the conversation. So we have a pretty active blog that updates both from an engineering perspective and business perspective where our network's going. We are also very active on social media. So we have a Twitter and a Discord channel. And you can present ideas. So in a lot of our GitHub repos, we encourage community involvement, PR requests, bug reports. Another way that you could get involved is through exploring public data sets. And so if blockchain is a space that interests you, GCP actually hosts public data through their BigQuery public data sets. All of the Bitcoin and like Bitcoin-esque chains store their data there. There's also one called Public Data Finance, which has a lot of like the bespoke blockchain data there. So like Polygon, Avalanche. Additionally, we have our own publicly hosted data set that's called CryptoStellar. And then lastly, we are hiring. Right now we have a data engineering position open. We do not have a data science position, but we are always looking for more data-driven people. And follow up on our career page and follow us on LinkedIn. And that is the end of my presentation.
Very cool, and we thank you very much for that. How about internships there, Sydney? I think there's probably a few people on here that might be looking at internships. Is that something that commonly might come up at Stellar? And if so, how would one apply for that? Because I don't see that sitting in that current openings on your homepage.
We do have internships. I don't know if we publicize those opportunities or how we source interns, but we do currently have an intern with us. Let me talk to some people and I can get back to you on how to get involved with that.
Super, great deal. All right. Looking at the chat, trying to just keep an eye on things for ourselves here. If there's any other, there's some clapping going on, virtual clapping I'm seeing, which is exciting.
So can you maybe explain a little bit more how Stellar is different from or similar to Ethereum?
Yeah, so the primary way that Stellar and Ethereum differ is in their consensus protocol mechanisms. So Ethereum uses what's called a proof of stake consensus protocol. And this means that individual validator nodes, they hold Ethereum tokens, and then they pay in order to commit blocks to the network using those tokens. Whereas Stellar isn't a pay for a reward model. It is, it's like a trust-based model where we arrive at consensus by implicitly trusting the validators on the network. So it's a much smaller network today. We have about 128 trusted validators, and there isn't a rewards-based model.
Thank you. We have another question in here from Tim. It's more of a comment. So Tim, if you want to post a question, feel free to do that in the chat or maybe speak up. But they said they are both used to facilitate payments and operate in a decentralized way, but there are too many differences to list.
Yeah, and Tim is very right with this. Another really large difference between Ethereum and Stellar is that Ethereum uses what are called smart contracts. And so there's this layer above the blockchain where if you want specific rules that have to be fulfilled before data is committed to the network, you could load that into a smart network or a smart contract, whereas Stellar has most of its features built into the protocol level itself.
Sydney, do you have some general thoughts? Just, I mean, if we're talking about the work that you do, can we ask you a couple of little brief questions that just might stimulate a little bit of additional conversation? So the typical, what's a day in the life look like for somebody like yourself as a data engineer and or a data scientist? What kind of day do you have? How do you break your day up?
So I think if you're working at like smaller startups like Stellar, our organization is only 100 people. And so our data department is 2. There's me, and then there's another software engineer who helps me build out pipelines. And so my day has a lot of variety to it. Some days I'm building out those data pipelines that is moving data from the chain over to BigQuery. And I'm making sure that these are robust pipelines so that we can trust the data that's being landed there. But a lot of my days also include data analysis. So all these case studies that I presented with you, those are just questions that people ask of seeing weird behavior, getting alerts, and they can't understand why, and they don't know how to tell that story. And so a lot of my afternoons are spent doing this ad hoc exploratory data analysis to try and understand what is going on.
Very cool. All right. Can you tell us maybe how you got here? I mean, career-wise, what brought you to your current role?
Yeah.
Because this is a new role, right? This is new for you?
Yeah, this is new for me. So I think like most careers, mine has been very non-linear. I was a math major when I went to university and actually hated computers. I didn't think I was going to do anything in computer science. And I was recruited at a career fair to work at a bank called USAA. It was an experiment to see if people with mathematical backgrounds could actually make that transition into data. So when I joined data, I was more of a visualization person and I really disliked it. And so I was able to move over to the machine learning space and worked as a machine learning engineer for about 5 years, where I was putting models in production. And that was really fun. But one of the considerations with some of these like traditional spaces is that they're highly regulated. And so anything that you're putting into production, you have to justify and be able to produce evidence of reproducibility, which was something that I didn't love. And so I wanted to go to a more flexible space where there was more innovation happening and just more excitement about the technology, which is how I ended up at Stellar.
Very cool. Okay.
We do have another question in the chat. So thank you for the interesting presentation. It sounds like SDF has taken the lead on doing analytics and fraud detection on Stellar so far. Are there any plans to move this work out into the community long term?
Yeah, so since we are such a small team, we do recognize that we could get more lift if we had more community engagement. And so one of our goals this next year in 2022, in 2021, we were really refining our data set and wanted to make sure that we had the quality data infrastructure that could support these types of use cases. And in 2022, that really is our aim. Our aim is going to be more for community involvement. And so what that's going to look like is maybe some Kaggle competitions where we solicit data science students like yourself to solve some of these problems that we know we have. We just don't have the expertise to solve. We're also looking at pursuing partnerships for capstones with Columbia University and other places where we can start bringing some of that expertise closer to our organization.
Sure, there'll be some excitement around that and interest for sure. Very cool. Okay. Hey, well, so let's talk about the job market real quickly. I'm just a couple of things. Is there a key skill or two that you could recommend that all students and or alumni make sure that when they leave our program, they need to have it? What would that be if you could kind of encapsulate that into a couple of different skills, if at all?
Yeah, okay, so one of the main skills that I always recommend is SQL. It sounds really silly, but working with some data scientists in the past, those who were SQL wizards and could answer any question they wanted, usually did a lot better at exploratory data analysis and didn't get as frustrated with data cleansing if their SQL skills were good.
Okay.
I think another skill is just inherent curiosity. Like, you can't be in one of these roles and not just be curious about the problem that you're working on, even if when you describe it to another person, it doesn't sound super interesting, but you need to be curious about the data that you're working with or the industry that you're working in. And then lastly, I think one of the most important skills for your students is just that passion to always be learning. This industry is moving so fast. So one day, computer vision might be the new hot thing, and then that changes the next day. And so that ability to change and adapt and be constantly growing and learning, even in your career, and not staying stagnant, is really important.
Super. All right. Well, let's see. Any other questions you're seeing there, Alexis?
No.
Okay. The last one I have might be, do you have any words of advice regarding job search?
Okay,
Any thoughts?
I have two words of
Please.
advice.
Okay.
So my biggest advice for people is to be picky. Do not jump at your first opportunity that you get. So sometimes it can be scary, especially as a student, if you're graduating in the spring and you don't have something lined up.
Yeah.
But make sure that the company that you're looking for actually aligns with the values and mission of what you want to accomplish. So don't jump at that first job opportunity if you feel like it's a bad fit, and don't let that anxiety force you into a position that you don't want to be in. And then my second one is that technical interviews are very hard. I failed a lot of interviews when I was looking for a new position, and that's not necessarily a reflection on your skills. And don't give up and keep trying. So some of those technical interviews, if you don't do well, just view it as practice and pick yourself up and get to the next one.
Great public service announcement. Actually, we're hoping to do some mock technical interviews with our alumni who would be kind of helping to do 15 to 20-minute sessions with students over in the spring semester. So greatly appreciate it. Great tips. Sounds super, super. Thank you very much for spending an hour in that box there with us. And stay well and safe travels and happy holidays to you. Nice meeting you, and thanks for your time today.
Thanks for letting me present.
Pleasure. All right. Thank you, everybody. Take care.
Bye.
Have a great
Bye.
week. Bye-bye.